Hi guys, welcome back to Techno Wizard. So today in this video I'm going to discuss the 5 most important questions of network, and these type of questions are being asked in every exam. So yeah, let's start with the video. And okay, so this is our first question. In this question is saying that the node voltage V in the circuit is, okay, so basically they have given us a circuit and we have to find out the node voltage V, which is nothing but the voltage across this 9 ampere current source, right? So in this question we can solve this question by the nodal analysis, right? Okay, so we'll solve this question by the nodal analysis. Okay, so in the nodal analysis we have to first mark the currents in the outgoing direction. So the currents will flow in this direction, so this will be a reference node, right? So suppose this is current I1 and this is current I2 and this is current I3, right? So nodal analysis states that the sum of incoming current is equal to sum of outgoing current. Here all the currents are outgoing, it means their sum will be equal to 0. It means current I1 plus I2 plus I3 is equal to 0, and the value of current I1 is, so current I1 is flowing in this direction, so this V is high potential, so it will be V minus 30 volt divided by 10 plus I2 current is minus 9, because this 9 ampere current is flowing in the upward direction but the I2 is in the downward direction, so the value of I2 is minus 9 plus I3 value is V minus 36 divided by 20 is equal to 0, right? So here negative sign is because this 30 volt source is opposing this nodal current I1. Okay, so now let's take the LCM, which will be 20, so it will be 2V minus 60, this will be minus 180 plus V minus 36 is equal to 0, right? So we can simplify it, so this will be 3V is equal to 180 plus 60 plus 36, that is equal to 276. So from here we are getting the value of V as 276 by 3, which is equal to 92 volt, right? So option D is correct. Okay, so next question is, applying the Norton theorems, the Norton's equivalent circuit to the left of the terminals A and B in the circuit is having the equivalent current source IN and the equivalent resistance RN. Okay, so in this circuit we have to find out the Norton current and the Norton equivalent resistance, right? So we know that a Norton equivalent circuit is represented by a current source in parallel with a Norton resistance, right? So this is our Norton equivalent circuit. So now we have to find out the value of these two. So first find the value of Norton current. Okay, so in order to calculate the Norton current, Norton current is nothing but a short circuit current, right? So this is short circuit current, so we have to short the terminals AB across which we have to find the current. So let's draw the circuit. So this is our 24 volt battery, so this is 24 volt battery, this is resistance R, this is current source, this is 4 ohm, and this is 4 ampere current source, this is 4 ohm resistance, this is 8 ohm, this is 8 ohm resistance, this is 4 ohm, and this is terminal A and this is terminal B, right? So this is positive, this is negative. Now we will short these terminals and the Norton current will be in the downward direction. So now we can find this Norton current. See here, this 8 ohm is connected in parallel with this short, so this 8 ohm resistance will be of no use and it will act as a dummy, because here this path is offering a low resistive path, so the entire current will flow from this here no current will flow, as a result of which it will be act as a domain, right? So suppose the voltage at this node is V1 and this is reference node. So now we can solve this network using the nodal analysis. So first mark the currents in the outward direction, right? So this current will flow like this. So let's apply the nodal. So now let's apply the nodal. So it will be simply V1 minus 24 by 4 plus, this is, suppose this is I2 current, this will be minus 4 because they are in opposite direction, plus V1 by 4 is equal to 0. So it will be I1 plus I2 plus I3 is equal to 0. So I1 current is V1 minus 24 by 4 ohm resistance, and I2 is minus 4 because they are in the opposite direction. This will be V1 by 4 is equal to 0. So after taking the LCM, it will be V1 minus 24 minus 16 plus V1 is equal to 0. So this will be 2V1 is coming as 40. So V1 value is coming as 20 volt. Now we have to calculate this Norton current. So this Norton current is IN is equal to V1 by 4, right? So here Norton current is equal to V1 by 4, which is equal to 40 by 4. So here Norton current is coming as 10 ampere, right? Now next we have to calculate the Norton resistance. So in order to calculate the Norton resistance, the procedure is that you have this voltage source will become short circuit and this current source will become open circuit, because we have to replace all the sources by their internal resistance, and the voltage source is having zero internal resistance, right? So voltage source is having zero internal resistance, it means it will act as a short circuit, and this current source is having internal resistance of infinite, it means it will act as an open circuit. So our circuit will reduce to, so this will short here 4 ohm and this will be open, so our circuit will become like, so here we have a 4 ohm resistance, and this voltage source will act as a short circuit. So I have open circuited the current source. So this was 4 ohm resistance, and here we have 8 ohm resistance. So this was 8 ohm resistance, this was 4 and this was 4. The current source is open circuited, right? And this was terminal A and this was terminal B. Now from here we have to calculate the value of Rn. So now we can clearly see that these two resistances are in series, so Rn will become 4 plus 4, and the overall combination is in parallel with 8 ohm resistance. So this will be simply 8 in parallel with 8. So we are getting the value of Rn is coming as 4 ohm, right? So now we have calculated the value of IN and RN, right? So we can put here these values. So option, I think we have done some mistake here. We are getting okay. So here V1 value is 20 volt, okay? So this was not 40, this is 20 volt. So the IN current is coming as 5 ampere. So this is 5 ampere. Sorry guys, I just written it wrong. Okay, so option A is correct. Okay, so next question is, consider the following circuit. So the circuit shown above attains a steady state with the switch S closed. What is the value of IT for t greater than or equal to 0 if the switch S is opened at t is equal to 0? Okay, so here we have a switch and this switch S is opened at t is equal to 0. It means for t less than 0 this switch S was closed. Alright, so it means first we will solve for at t is equal to 0 negative. It means just before the switch S is opened, the switch was closed and the circuit was under the steady state. They have already mentioned, right? So the circuit was under the steady state, and we know that under the steady state inductor act as short circuit. So under the steady state, inductor act as short circuit and capacitor act as open circuit, but in this circuit we have no capacitor. So this inductor will act as a short circuit, and then we will calculate the current flowing through the inductor. So for t less than 0, our circuit will be like this: is 20 volt battery. Here we have another battery, so this is plus and minus. This is 10 volt, this is 20 volt battery, right? So here we have a resistance of 30 ohm, and early 40 less than 0, the switch is closed. This is 30 ohm and this is 20 ohm resistance, right? So now the inductor will act as a short circuit. So this is 20 ohm and the current flowing is I, right? So now we have to calculate the value of this current. So suppose this 20 volt battery is giving a current of I1, right? And this 10 volt battery is giving a current I2. Now applying the KCL at this node, we will get the value of current in this branch is I2 minus I1, because here I2 current is coming and here I1 current has gone, so remaining current will flow in this branch. So now here I2 current will flow, so this I2 current is equal to I current. Now we can apply the KVL in this loop and can find the value of the current I. So now I'm going to apply the KVL in this loop. It will be simply, so I'm starting from here, so this is minus 10. Here no resistance is there, so this will be simply 0. So current is entering into this terminal, so this will be positive and this will be negative. So this is plus 20. Current flowing is I2 is equal to 0. It means 20 I2 is equal to 10. So the value of I2 is coming as 1 by 2, which is 0.5 ampere, and the current I is equal to I2. So the current I is equal to I2, which is equal to 0.5 ampere. So we can write it like that: I0 negative is equal to I0 positive is equal to I of 0, because this is the current flowing through the inductor for t less than 0, which is equal to 0.5 ampere, and I0 negative is equal to I0 positive because inductor does not allow the sudden change in current, right? Because for changing the current suddenly in the inductor we need infinite amount of voltage, and which is not possible, right? So that's why inductor does not allow the sudden change in current. Okay, so now we will draw this circuit for t greater than 0. So now for t greater than 0, switch is opened, right? So now our circuit will become, so here we have a 20 volt battery. So this is 20 volt battery. Here we have another battery which was 10 volt, so this is 10 volt battery. Here we have a 20 volt battery, and this is 30 ohm resistance. Now the switch is open, so this is 20 ohm. Now the inductor will remain as it is, so this was 1 Henry and the current flowing is I, right? So now the expression for the current is given by, so I of t is equal to I of infinite plus I0 positive minus I of infinite into e to the power minus t by tau. So this is the expression of current flowing through the inductor at any instant of time, and I of infinite is the current through the inductor under the steady state condition, and I0 positive is the current through the inductor at t is equal to 0 positive, and this is same, and tau is the time constant, right? So now we have to calculate the value of I infinite. Now we have to calculate the value of I of infinite. So under the steady state, this inductor will act as a short circuit. So overall circuit will be these two voltage source will be there and these two resistance will be there. So I infinite will be nothing but our voltage value will be 30 volt divided by R equivalent is 50. So we are getting the value as 3 by 5, which is equal to 0.6 ampere, and we have already calculated the value of I 0 positive. Now what is time constant? So time constant tau is given by L by R equivalent, right? Because here we have the two resistances, so L value is 1, and what will be R equivalent? So in order to calculate the value of R equivalent, the voltage source will act as short circuit, so these two resistance will come in series. So we are getting 1 by 50 seconds, right? So now we will simply put these values in this equation. Okay, so I of t is equal to I of infinite plus I 0 positive minus I of infinite e to the power minus t by tau. So I of infinite we have calculated is 0.6 plus I 0 positive is 0.5 minus 0.6 e to the power minus t by time constant was 1 by 50. So this can be simplified as 0.6, it will be minus 0.1 e to the power minus 50 t I of t. So this will be in ampere. So let's see the option. So option B is correct. Okay, so next question is the resonant frequency of the given series circuit is. Okay, so in this question basically two concepts are involved. One is resonating frequency, another is mutually coupled circuit, right? So we all know that the formula for the resonating frequency is given by 1 by 2 pi root LC, but here we have the two inductors present, so it will be L equivalent. Now we have to calculate the value of L equivalent. Okay, so L equivalent is given by, so here we have two inductors. Suppose this inductance is L1 and this is L2, right? So now suppose if the current is flowing in this direction, so for the inductor L1 the current is entering this dot. Now similarly for this inductor L2 the current is also entering this dot, it means they are supporting. So the formula for the L equivalent will become L1 plus L2 plus 2m plus, because it is supporting this current, but if this dot is present it at this side, then it will be minus 2m because they will be of opposite nature, right? So now let's put the value. The value of L1 is 2 Henry, so it will be plus 2, and L2 value is also 2 plus 2, m value they have given us 1 Henry. So we have calculated the value of L equivalent is coming as 6 Henry. So now let's put in the formula. So it will be 1 by 2 pi, the value of L equivalent is 6 and the C value is 2. So this is equal to 1 by 2 pi root 12, and root 12 is, so this is F naught, so this will be root 12 is 2 root 2, it means it will be 1 by 4 pi root 3, right? So option B is correct. Okay, so root 12 is 2 root 3, so this will be in hertz, so option B is correct. Okay, next question is consider the two-port network as shown. The hybrid parameter h12 is. Okay, so for this network we have to calculate the h parameter h12. So let's see what is h parameter. So h parameter is defined as v1 I2, oh sorry, this will be I2 is equal to h parameter So now let's find the current in each branch. So from here I1 current is coming, from here I2 current is coming, and from here alpha I1 current is coming. So in this R3 resistance the current flowing is I2 plus alpha I1, right? We can find this value by KCL. Similarly, the current in R2 resistance will be I1 plus I2. So we can write the expression for the V1 by applying the KVL in this loop. So we are getting the value of V1 as, so V1 is equal to R1 into I1 plus resistance R2, current flowing is I1 plus I2. It can be simplified as R1 plus R2 into I1 plus R2 into I2, right? So suppose this is equation A. Similarly we can find the expression for V2 also. So V2 will become R3 into current flowing is I2 plus alpha I1 plus R2 into I1 plus I2. So we can simplify this equation. So V2 is coming as, V2 is equal to, I'm writing the equation again, R3 into the current flowing was alpha I1 plus I2 plus R2, the current flowing was I1 plus I2, right? So this will be alpha R3 I1 plus R3 into I2 plus R2 R1 plus R2 into I2. Now taking I1 common, this will be alpha R3 plus R2 into I1. Now taking I2 common, this will be R2 plus R3 into I2. So this is the expression for V2. So suppose this is equation B. Now we have to calculate the H12 parameter value. For that I1 current will be 0. So if we will substitute the value of I1 0, so we are getting the expression of V1 as R2 into I2, right? So from equation A, as I1 current is 0, we are getting the value of V1 as R2 into I2. Similarly, the expression of V2 will become, we will substitute the value of I1 is 0, so we are getting the value of V2 is equal to R2 plus R3 into I2. So our H parameter, H12 we have to calculate, right? So H12 is V1 by V2. So H12 is equal to V1 by V2 for current I1 is equal to 0. So we have calculated the value of V1 is coming as R2 into I2 divided by R2 plus R3 into I2. So we are getting the value of H12 as R2 by R2 plus R3. So option D is correct. So thank you guys for watching this video. Please like, share and subscribe to the Technovizard channel. Bye guys.